Okay, so now we're in section 5.3, and we're going to get into special methods. So let's get into the curriculum. All right, so now we're in 5.3, special methods. Every class has a few special methods that belong to it, regardless of whether or not we define them. Exactly how every class obtained these methods will be explored in a future lesson. For now, let's look at two important examples of these methods. 5.3.1, toString. The toString method returns a string representation of a class. Calling toString on a class that you've written will result in something like this. So here we have the student. We made a variable called person, and we're storing that new student instance, and we're passing in the word Violet, or the string Violet. Now on line 2, we have a system.out.println person.toString. In the console, this is what it's going to print out. org.launchcode.java.demos.class2 student, and then this is the number that it passes. Here we call toString on a student object. The default toString implementation is generally not very useful. Most of the time, you'll want to write your own toString method to override the default and provide better results. See, this doesn't make too much sense, does it? But let's go a little bit further. Here's how we might do it for students to produce a much more friendly message. So here we go. So we got public string toString method. And this is what we wanted to return. We wanted to return the name plus credits plus number of credits plus GPA all the way to the end. Now we create that instance. Student person, new student, Violet. Now we do person to string method. And this is what we get printed to the console. That makes more sense, or it's more useful. In the example, we defined the toString method to return a string that reports the class fields name, number of credits, and GPA in a clear manner. Note that the toString is often implicitly called for you. For example, the output above could have been generated by the following code, which calls toString on person within system.out.println. Now, 5.3.2 equals. Suppose we have two objects of type student, say student 1 and student 2, and we want to determine if they are equal. If we try to compare them using the double equal sign, we will likely get a result we did not expect. This is because student 1 and student 2 are reference variables. Okay, let me kind of stop there for a minute, because this goes over into what we call memory. Things get stored in memory. Whenever we are comparing something based on a reference, if it's in two different slots, because of student 1 and student 2 is stored in two different places in the memory, then they are not going to give you the results you're looking for, because they are comparing two different references as opposed to comparing an object. So here, which means they hold a reference to or the address of. The actual student object, student 1 and student 2, evaluate as equal only when they have the same memory address. To state that again, student 1 and student 2 would be equal only when they refer to or point at the exact same object. Consider the example below, which creates two student objects. Now that, like I said, that may be a little bit confusing to you because you can't see it. It may not make sense because you don't see it in memory. So if you had a graph that was created and it had 100 slots on that graph, let's say a table. And so you got 1 to 100. The top, the row cross has 10 and the columns have 10. So it equals out to be 100 squares. So what it's saying here, if student 1 is in square 2, 2 or 2, 2, which is 2 row, 2 column. And if also student 2 is in the same memory address, they will be equal to 2, which would be column 2, row 2. But let's go and let's continue over with the example so we can see what the curriculum is saying. So we have student 1, new student, Maria 1, 2, 3, 4. And then we have student 2, new student, Maria 1, 2, 3, 4. So if we print these both out and then we do a printout of the student 1 is equal to student 2, it's going to say false. Why? Because these would be in 2 different memory slots. So like I was saying, you have that table. If student 1 is in 1, which is row 1, column 1, and memory 2 or student 2 is in row 2 and column 2, they're not going to be equal because they're in 2 totally different places. That's what that means. But now, even though the objects have the exact same keys and values, student 1 and student 2 point to 2 different memory locations. Therefore, the equal check returns false. This is not usually how we want to compare objects. For example, we may want to consider 2 student objects equal if they have the same name, email, or student ID. The equal method determines if one object is equal to another in this sense. We introduce the method when discussing strings, but it also applies to all other classes. The code below shows that the use equal method to compare 2 students. Note that they have different names, but the student ID indicates that they are actually the same person, as we can see in this example. Bono 1, Bono 2. Paul David Newsom 4, Bono 4. Bono 1 equals Bono 2, system printout. And it says it's the same as Bono 2 get name. Now, let's read a little bit further and then I'll explain. If we don't provide our equals method, the default option only considers 2 objects equal if they are the same object, which means they point to the same memory address. This is identical to the behavior we see when using the equal operators, Bono 1 double equal to Bono 2. In the example above, we created 2 different student objects. So the expression Bono 1 equals Bono 2 evaluates to false. In order to compare the 2 objects based on their properties rather than their memory references, we need to define our equals method like this. The difference between the comparison carried out by the default equals method and by the equal operator, and how we would like to compare our classes, is the difference between identity and equality. 1. 2 objects are identical if they both point to the same memory address. In essence, they are the same object. If object 1 and object 2 are identical, then changing one property value in object 1 also changes the value for object 2. 2 objects are equal if the values they store are the same at the time of comparison. Student 1 and student 2 point to different memory addresses, but their values are all the same. Thus, we can consider them equal even though they are not identical. The default equals method and the equal operator test for identity, whereas we want to test for equality in more detail later. But for now, recognize, let me go back over that. The default equals method and the double equal operator test for identity, whereas we want to test for equality instead. We can do so by overriding the equals method. We will discuss overriding in more detail later, but for now, just recognize that it involves defining different behaviors for existing methods. The two things we consider equal, even two things we can consider equal, even if they do not have all the same values. In the case of the student class, we might specify that the two student objects are equal if they have the same ID numbers. We will then write a new method definition for equals as follows. Now, let me explain something to that. This comes to databases. Whenever you create a database, we have what we call a primary key. A primary key doesn't change. It's unique. And therefore, the reason why we say student ID and not go by like a telephone number, or if we go by the last name, those can be different for different people. But one thing that doesn't change, like for instance, your social security number is unique to you. Also, what can be unique is if we said an email address, but that's only in that database. So a unique like social security number, no matter where you go, according to the IRS, your social security number is yours. It's you. No matter if you change your name, you keep that same social security number, unless you're in the witness protection program and the government issues you a new identity. But I just want to point that out so you can understand how we're able to distinguish how an object is the same by focusing on the ID. So here's the example. Public Boolean equals object to be compared. We have a student, the student is what it's called. And then we're assigning it to be compared to student. Return student, get student ID equal to get student ID. So we want that to equal. For the student, we want those two IDs to equal. Now, if we evaluate Bono 1 equals Bono 2, we will get a result of true since the student IDs match. One catch of working with equals method is that its input parameter must be of type object, even if we're working in a class like student. The reason why will become more clear in the next lesson when we introduce the object class. For now, the practical implication is that we must convert our or cast the input to be compared to be of type student with the syntax student. So this is how you cast something. So this is what casting means right here. It's when you put something in parentheses and we're going to cast student to be compared to. And we'll go over that more in the upcoming chapter. That's why I say don't get stuck on something. If you don't understand it fully yet, just keep going, because eventually we'll introduce you to something else. We build upon what you already learned, and then it brings it all together later on. So, like I said, don't get stuck here. Keep moving forward. Now, we talked about the catch, and then we did the casting. So the input to be compared to by the students with the syntax student to be compared. Then we compare the converted student ID bono2.id to that of the current bono1.id. Are they the same thing? Because we're passing in that ID property for both. And we notice all the way up here that they both have the number 4, although the name is different, but that ID is the same. Remember, Social Security number? So here we go. Here's a visualization of the concept of equality and identity. Let's look at equality. Student 1, student ID 4, name Bono, type student. Student 2, student ID 4, name Paul Davidson or David Hewson, type student. When you test for equality, you look at 2 different objects and compare some aspect of them to each other. So we decided to pick the ID. So we chose to pick the ID. Now, when you test for equality, you look at 2 different objects and compare some aspect of them to each other. So one thing we want to compare is the ID, because that's something that's unique. And if this was a different number, if this was 5, and because we were testing the ID, then we will know, or we were comparing the ID, then we know that there will be false, even if the names were the same, or if anything else was the same. Everything else was the same, but that ID was different, then we know that it's going to be false. Now let's look at identity here. When we're checking for identity, we have student 1, student 2. And they're both pointing to student ID 4 named Bono, type student. Everything in here is the same. Now, when you test for identity, you look at 2 variables to see if they reference the exact same object. Again, are they pointing to the same object that's in memory at that address? Okay. Now, 5.3.2.1, coding a new equals method. You'll often want to implement equals method yourself. When you do, be sure you understand the best practice around how the method should behave. These are a little more involved compared to coding a new toString method. So there's a link right here that you want to go ahead and click and look at. In fact, the equals method we define above isn't very good by most Java programming standards. Let's improve it. 5.3.2.1.1, problem 1. The method argument cannot be converted to a student instance. When we attempt to cast the argument to be compared to type student, we'll get an exception if to be compared can't be properly converted. This happens if something other than a student object gets passed into equals method. To prevent this from happening, we'll return false if to be compared was not created from the student class. To check, now notice that keyword check. So if I'm thinking check, I'm thinking conditional. This, we use the get class method, which is available to every object, similarly to toString. So here we go. Boolean equals object to be compared. We're making this an object type. That's what that is. If to be compared dot get class method, not get class, return false. So if it wasn't in the get class method, return false. Student is the type, the student is the variable, and we're casting student to be compared to that's going to be stored into the student. Return the student get ID equal to get ID. So if this is, after we do our check, if this is false, it stops there. But if this comes back to be true, then we're going to come down here and run this block of code. Line 3 ensures that the 2 objects that we want to compare are created from the same class. Now here we go. 5.3.2.1.2, problem number 2. To be compared might be null. If to be compared is null, then to be compared.getClass throws an exception. This is an easy issue to fix. Just compare the objects to null. If the comparison evaluates to true, then we know the object is null and equal should not return false. Again, here's another key word: compare. Compare and check. Compare and check. Think conditionals. So here are our conditionals to check. And if everything is good, then we're going to run that block of code. Line 3 checks to compare for null, preventing an error in line 7. Checks the class to be compared, preventing an error in line 11. So here, 5.3.2.1.3, problem 3. The two objects to compare are the same object, identical. This is less of a problem and more of a way to improve our equals method. If to be compared is the same literal object that we are comparing it to, then we can make a quick determination and save a few checks. So here we go. Here's our example. We're comparing this, this is an object that is representing, and then we're comparing for null, and then we're comparing the class again to make sure if that's false, and if we get past all those checks, then we can run that block of code. Line 3 checks for identity. If true, then the remaining checks become unnecessary. 4.3.2.2 components of equals. Almost every equals method you write will look similar to the last example above. It will contain the following segments in this order. 1, a reference check. If the two objects are the same, return true right away. Null check. If the argument is null, return false. Class check. Compare the classes of two objects to ensure a safe cast. Return false if the classes are different. Cast. Convert the argument to the one type of our class, so getters and other methods can be called. Custom comparison. Use custom logic to determine whether or not the two objects should be considered equal. This is usually be a comparison of properties or fields. 5.3.2.3 characteristics of equals. Now that we know how to write an equals method, let's look at some characteristics that every such method should have. Following the general outline above makes it easier to ensure that your equals method has 3 characteristics. 1, reflexivity. I don't know if I'm saying that right. For any non-null reference value x dot equals x has a parameter should return true. Symmetry. For any non-reference or any non-null reference value, x and y, x dot equals y should return true if and only if y equals x also returns true. Transitivity. For any non-null reference value x, y, and z, if x equals y returns true and y equals z returns true, then x equals z should return true. Consistency. As long as x and y do not change, the x dot equals y shall always return the same results. Non-null. For any of non-null reference value x dot equals null should return false. If you think back to what your math classes have to say about equality, then these concepts make sense. Using general approaches outlined above to implement equals will make it easy to meet these characteristics. However, always check your method. Missing one or more characteristics can be disastrous for Java application. Tip: Seasoned Java developers would tell you that every time you implement your own version of equals, you should also implement your own version of hash code or hash methods or hashcode methods.hashcode method. It's another special method that every class has. Understanding hash code methods would take us a bit far afield at this point, but we will be remiss not to mention it. If you want to read more, check out this article and this Stack Overflow. 5.3.2.4, the takeaway. You may not need to write your own equals method for every class you create. However, as a new Java programmer, remember the following. Always use equals method to compare objects. This is essentially true when working with objects of types provided by Java, such as a string. A class that is part of Java or the third-party library will have implemented equals method in a way appropriated for the particular class, whereas double equal will always check to see if two variables refer to the same literal object. Here's some references and check your understanding. Okay, so that's the end of this section. Okay, we'll go to the next section. Remember, the more you practice, the more you improve. See you in the next one.